I'm going to discuss the carbon and its compounds. This is according to ICSE syllabus class 8. Okay, so in my last video, I stopped with the allotropic forms of carbon. So there are two allotropic forms of carbon. That is, one is crystalline, another is amorphous. Crystalline are subdivided into diamond, graphite, and fullerenes, and amorphous into charcoal, lamp black, and coal. Okay, charcoal can be wood charcoal, sugar charcoal, animal charcoal, or you can say bone charcoal. Then coal can be divided into coke and coal gas. Okay, next is we start discussing about the allotropic form of carbon, which is a crystalline form. That is, one is graphite. Okay, two allotropic forms I told you. One is crystalline, another is amorphous. So we'll first start with the crystalline form. That is, first is graphite we'll discuss. So this graphite is a natural crystalline form of carbon. Okay, natural one is found as a mineral of lead. Okay, a mineral of lead, which is known as plumbago, it has the natural form of graphite. That is found both in Sri Lanka and Siberia. In India, graphite is found in, this mineral form is found in Jammu and Kashmir, Bihar, Odisha, Rajasthan, and West Bengal. Then how the graphite is prepared? Okay, this is the natural one which we find, but artificially, how can this be prepared? It is prepared by heating powdered coke. When we heat powdered coke with a little sand oxide, that is ferric oxide, if we add with a little sand to it, to coke, powdered coke, and by heating that in an electric furnace to a very high temperature, that is 3000 degrees centigrade, then pure graphite is formed. Okay, so the reaction will be like this: sand, SiO2, silicon oxide, okay, that will combine with carbon at 3000 degrees centigrade in presence of ferric oxide. It will change to carbon monoxide and silicon carbide. Okay, now this silicon carbide in presence of heat will decompose to silica and carbon. Silicon and carbon. Okay, that is the graphite. Okay, then what is the structure of the graphite? In a graphite molecule, each carbon atom is linked with 3 neighboring carbon atoms. Okay, graphite molecule is linked with 3 neighboring carbon atoms, and thus a flat hexagonal arrangement of atoms is formed. Okay, these groupings are arranged as layers or sheets. Okay, 3 carbon atoms it is attached to, forming a flat hexagonal arrangement of the atoms, and these flat hexagonal arrangement, they lie one above the other, forming layers or sheets, okay, piled one on the top of the other, and these layers are held together by weak forces so that they can slide over one another, and they can be slippery, soft and slippery, and that's why they can be used for as a lubricant. Okay, and for softness they can be used as lead of the pencils. Okay, that I'll come later on when we'll discuss the uses of the graphite. Okay, so first you should know that they are attached, these layers are attached to each other by weak forces, and so that they can slide over one another, and that's why graphite is soft and slippery. Next, it is the physical properties of graphite. Graphite is grayish black opaque substance. They have a metallic luster. Okay, like metals, no, they have a luster on them, that is, they shine like that. So they have a metallic luster. They are grayish black opaque substance. Okay, light cannot pass through. It's an opaque substance. Density is 2.39 grams per centimeter cube, and it is stable towards heat and has a very high melting point of 3700 degrees centigrade. That is, when you heat about 3700 degrees centigrade, then graphite melts. Okay, then it is soft and greasy to touch. It leaves a black mark on the paper. That's why it is used as a lead of the pencil. Okay, the pencil which we use for writing, that the lead in that, this is due to this is made up of graphite, and this is because it leaves a black mark on the paper. It's a good conductor of heat and electricity, as each carbon atom present in it has one valence free electron, which is free. Okay, that's why it's a good conductor of heat and electricity. It's mainly electricity. Okay, it's an insoluble in ordinary solvents. It is insoluble in ordinary solvents. In ordinary solvents, it does not dissolve. Okay. Next is, we come to the uses of graphite. What are the uses of graphite? I told you two uses. I told you one is used as a pencil lead. Another is it can be used as a lubricant. Okay, so I'll discuss on those. So first is used as a pencil lead. Why? Because as the layers of the carbon atoms are in the graphite, they can slide over one another. Graphite is soft, and also they leave black marks on the paper, and that's why they are used as a lead of the pencils. So what happens, how to make that lead? What happens, graphite it's combined with clay and powdered sand. Okay, graphite is combined with clay and powdered sand to form the pencil lead. And the hardness of the pencil depends on the amount of the clay. The hardness of the lead, that depends on the amount of the clay which is present in the lead. Okay, now it can be used as electrodes. Graphite, as they have a one valence electron that is free, it's a good conductor of electricity, and it does not react with any acid or alkalis, because it does not dissolve, or it is insoluble in ordinary solvents, so it does not react with acids and alkalis, and therefore they can be used for making electrodes. Okay, then they are used as dry lubricant. Okay, I told you they are the carbon layers in the graphite, they can slide over one another, and graphite is slippery, and so they can be used as dry lubricant in powdered form, suspended in oil. Okay, these type of lubricant is used in those machinery where oil cannot be applied. This type of lubricant is known as graphite grease. Okay, then it is used as a heat resistant. It is used in heat resistant crucibles. Why? Graphite combined with clay forms crucibles, crucibles which are heat resistant. Okay, this is due to that the clay can withstand heat, and due to graphite that can conduct heat. Okay, so what happens, these two are combined together, no, graphite and clay combine to form this crucibles which are heat resistant. Why this happens? Because the clay can withstand the heat and graphite can conduct heat, so both are combined together, they become heat resistant. Okay, so then next is used in nuclear reactors as moderators. In nuclear reactors, atoms of uranium or thorium, they split, and excess of the neutrons which can lead to an explosion. Okay, when they split, there is excess of neutrons which come out, which can lead to an explosion, and therefore what happens, graphite is added to that in this new reaction when it is taking place, that is atoms of uranium or thorium, when they are splitting, this graphite is added to slow down the excess of neutrons, that is, so that now the neutrons which are coming out in excess, that does not come out very fast, or not too much of neutrons do not come out. To slow down that one, graphite is used. They are used as moderators in these reactions. Okay, then used for making carbon brushes for electric motors, and they are also used for making artificial diamonds. Okay, next we come to diamond. So what is diamond? Diamond is it's also a form of carbon. It is the purest form of carbon. Okay, diamond is the purest form of carbon. An impure form of carbon is coal. Okay, and graphite is in between the two. then occurs in all shapes and sizes. Diamond occurs in all shapes and sizes, and they are found in South Africa, Brazil, Namibia, Russia, Australia, USA, and India. India is found in Golconda, which is in Telangana presently, and Panna in MP, that is Madhya Pradesh. Then how this diamond is prepared in the nature. Okay, in nature, what happens, the carbon which is present in the earth, that we know that molten magma that lies inside the earth, okay, in the earth's crust. So carbon sometimes the present which is present in the earth, that dissolves in this molten magma. And when this molten magma is pushed towards the surface of the earth, this solidifies, this gets solidified. Okay, now the iron which is present in the magma expands and exerts pressure, great pressure on this carbon. This helps the carbon in crystallizing. When they are exerting the pressure on the magma, no, and the iron which is present in the magma, that is exerting the pressure on the carbon, that crystallizes out in the form of diamonds. Okay, so diamond bearing rocks are kimberlite rocks. Okay, the rocks which contain this diamond, they are kimberlite rocks, which is named after Kimberley mines, which is present in South Africa. Now, I told you that graphite can be used for making artificial diamonds. So, in the previous process, I discussed how this diamond is formed in nature. Now, I'll discuss the preparation of diamond artificially. And I told you that graphite can be used as a preparation of diamonds. So graphite, when it is heated about 3000 degrees centigrade, that is high temperature and high pressure, graphite changes to diamond, which is small in size, but it changes to diamond. Okay, now the value of the diamond depends on its weight and the impurities which are present in it. Okay, the weight of the diamond is calculated in carats. Okay, 1 carat is equal to 0.2 grams. Some famous natural diamonds are Kohinoor and Pitt diamond, which is mined in India. These two are mined in India. And Cullinan diamond, that is found in South Africa, that is mined in. And the biggest diamond which is ever found is Cullinan diamond. Okay. Now, they are generally colorless, transparent diamonds are costliest. Okay, colorless, transparent diamonds are costliest as they have a negligible impurity, because they have less impurity, almost null. Impurity is almost none. Therefore, that's why they are colorless and transparent, and so they are costliest. So more impurity, less value of the diamond it will be. The color of the diamond is due to the small traces of metallic oxide and salt which is present as impurity, and the black diamond is due to the presence of copper oxide as impurity. Okay. So I think I'll stop here. I'll continue with the discussion of this diamond in my next video, and the other allotropes I'll discuss. So please go through this. If you have any doubt, please do let me know. Write in the comment box, share with your friends, press the like button, and also do subscribe to get the notification of my next video. Thank you for watching and have a good day.